Well, as you can see here, we're continuing doing examples with the general power rule, but the 2 or 3 examples we have here, I would say, are a little bit more complicated. And what we're going to find is if we learn how to write in calculus, then we have a bunch of little problems to deal with, and so we can take something that looks complicated and make it a bunch of little problems. So we look here at the function f of x, and it's x squared plus 4 to the power 3 times 5x minus 1 to the power 4. And we can imagine that somewhere along the way, we're going to have to deal with the general power rule. But the first thing we really should notice is this is the product of 2 things. That is, the u is the x squared plus 4 to the 3rd power, and the v is the 5x minus 1 to the 4th power. So, you know, we've kind of seen this idea. Again, it's very important to notice before we do this problem and get too far into it that we must use the product rule before we do anything else. So the product rule first. The general power rule is going to be required along the way. Okay, but let's remember how that, once again, let's remember that when we're dealing with the derivative, so this is just one of these side notes, if f of x is u times v, then f prime of x is u times v prime plus v times u prime. But most importantly, it's first times derivative second plus second times derivative of first. Okay, so now we get ready to implement or use calculus notation to write that. So in this case, the first function is the x squared plus 4 to the 3rd power. So we write down first function. And then we have to multiply that with derivative of. Well, there's derivative of. Now, derivative of what? Derivative of the second function. And the second function is 5x minus 1 to the power 4. And then we say plus. And the plus is we write the second function, that's the v, the second function times the derivative of the first function. Well, it's just the second function, which is 5x minus 1 to the power 4. And then we multiply that with the derivative of. The derivative of, that's what that means. The derivative of the first function. Well, the first function is the x squared plus 4 to the power 3. So we've written out in calculus terms what it is that we have to do. So now we go back and do it. So f prime of x, and the do it is we have to actually find derivatives in this case, don't we? So we look at this first derivative. And see, now it's when the general power rule shows up, because to find the derivative of 5x minus 1 to the 4th power, we have to use the general power rule. And so we bring down the 4, okay, and put it in front of the parentheses and decrease the power by 1. So now it'll be a power of 3. Now, then we have to multiply with the derivative of the 5x minus 1. And the derivative of 5x minus 1 is just 5. So this is very important to recognize that that came from the derivative of the inside. See, that's just the derivative of the inside. That's how that came about. Okay, plus. Well, now we have the 5x minus 1 with the power of 4 on it, and we have to find the derivative of x squared plus 4 with the power of 3 on it. And to do that, we have to use the general power rule. So we bring down the exponent 3, and we put a new exponent on the parentheses of 2, decrease the exponent. And then we multiply with the derivative of the inside. That is the derivative of x squared plus 4, and that gives us a 2x. So let's remember that that came from the derivative of the inside. And it's important that that's part of what we do. Inside being x squared plus 4, that derivative is 2x. Okay, let's take that long expression and let's just reorganize it. That's all we're going to do. So we see in the first part of that expression is all of this. And I notice I've got a 4 factor and a 5 factor. Well, 4 times 5 is just 20, so I'm going to put that 20 in front, and then I have an x squared plus 4 with a power of 3, and a 5x minus 1 with a power of 3. Okay, and now I come over to the second term after the plus sign, and I notice I've got a 3 here that's going to be multiplying with a 2x. I can do that easily. 3 times 2x is 6x. I'll write that in front. And then when I have left, okay, I have a 5x minus 1 to the 4th power and an x squared plus 4 to the 2nd power. But what I would like to do is write these in the same order as the first part of this expression. So I'm going to write the x squared plus 4 first to match the first part of this expression, and that exponent is 2. And then I'll write the 5x minus 1 to the 4th power, of course, to match the same order I have in this part, okay? And that's really what I'm doing that for. Now, I'm in a position that things are organized. And when things are organized, then I ought to be able to look at this and decide whether I have a common factors or not. And so notice when we compare 20 and 6x, well, 2 is a factor of 20 and of 6x, isn't it? And since 2 is a factor of both of those, that means 2 is a common factor. And then, see, I was comparing here and here. Now I'm comparing the x squared plus 4, and I've got another x squared plus 4 over here. So x squared plus 4 is a common factor. But if we're going to factor a common factor out, we need to know the right exponent. And we always use the smaller of the two exponents. And the smaller of the two exponents in this case is 2. First one's an exponent 3, the second one's an exponent 2. Okay, now I'm noticing that I have 5x minus 1 that appears in both of these. And so 5x minus 1 is a common factor. But to use the right exponent, I have to use a smaller of 3 and 4. And the smaller of the exponents 3 and 4 is 3. Now, what I've written there is just a common factor. I've factored out a common factor. So now I have to decide what goes in the brackets. And the plus sign that I put here is the plus sign above that separates the two parts. So I'm thinking 2 times 10 is going to give me the 20 in the first part. And I'm thinking x squared plus 4 to the second power times x squared plus 4 to the first power is going to give me x squared plus 4 to the third power that is required. Well, I can see that I've kind of squeezed myself out of room here. I apologize for this. I apologize. I'm really going to need more space. So I'm going to kind of scratch out what I have there. I wish I was on a chalkboard so I could just erase that. Okay, this is what I have, but I need longer brackets, don't I? Okay, so it's kind of redoing this. I need longer brackets. And the 2 times the 10 is giving me the 20 that's way up here. And the x squared plus 4 to the second power, it needs to be x squared plus 4 to the first power to give me this x squared plus 4 to the third power. And then I need a 5x minus 1 to what power? Oh, I don't need that at all because I need a third power and I've already got a third power. So I actually don't need that. I kind of got ahead of myself. Well, then there's the plus sign. Now 2 times the 2 that's in front here, and it's this 2, in front here times what gives the 6x that we have there? Well, we need a 3x, don't we? Now we need to create this x squared plus 4 to the second power. And we've got an x squared plus 4 to the second power, so we don't need any more x squared plus 4s. Now we have a 5x minus 1 to the third power here, and we've got to multiply to get a 5x minus 1 to the fourth power. So we need a 5x minus 1 to the first power, and that's what I've written here. Okay, now, when I'm cleaning this up, and I've made a big mess out of it to try to explain what I'm doing, I have the 2 and the x squared plus 4 to the power 2 and the 5x minus 1 to the power 3. And inside these brackets, I'm going to try to clean that up. In the first position, I've got a 10 times x squared plus 4. I multiply that out, that's 10x squared plus 40. And in the second position, I have a 3x times the 5x minus 1. When I multiply that out, I'll get a 15x squared minus a 3x. And then I see that inside these brackets, I'll be able to combine terms. So f prime of x is 2 times x squared plus 4 to the second power times 5x minus 1 to the third power. And the brackets, I'm going to clean up what's inside and convert the brackets to parentheses. So I have a 10x squared plus a 15x squared, which is 25x squared. And then I have a minus 3x over here, and what? A plus 40. Okay, so that's the simplified version. In fact, now there's really nothing else I need to do. I simplified it completely, and this is my result. This is the derivative. Now, on the next page, we're going to deal with something that includes a fraction. So let's look at this next more complicated example. Okay, you can see here, notice I've decided to change the function name just to mix things up. We're to find g prime of x, or the derivative, if we know g of x is this complicated function. 3x minus 1 squared on top, and 5x plus 2 cubed on bottom. Now, here we have to think differently, that we actually have a fraction. And so we're really thinking that our g of x is a u divided by v. And knowing that, the way we find such a derivative, we use the quotient rule, don't we? And the quotient rule says, okay, take the denominator, multiply with the derivative of the numerator, and then subtract the numerator multiplied with the derivative of the denominator, and divide all of that by the denominator squared. So in this problem, we must use the quotient rule first, not the product rule. Okay, quotient rule first. So we're going to apply that using calculus language. So to find g prime of x, okay, it's going to be a long fraction. How do we do this? We take the denominator, see the denominator, that's what the v is, isn't it? The denominator, which is 5x plus 2 cubed, and multiply it with the derivative of, well, what is it? It's the derivative of the numerator. Well, the numerator is 3x minus 1 squared, okay? And then we subtract. And in the subtraction, we take the numerator and multiply with the derivative of the denominator. Well, the numerator is 3x minus 1 squared, and we multiply that with the derivative of the denominator, okay? And the denominator is 5x plus 2 cubed. And then we take all of that and we divide by the denominator squared. Now the denominator is 5x plus 2 cubed, and that's what we have to square, is the denominator squared. Okay. We've written down the directions using calculus language on what it is we've got to accomplish. So now we go back and we find the derivatives and we do the squaring. Okay, so here we go. G prime of x is a fraction. Okay, again, it's going to be a long fraction, isn't it? And it starts out with a 5x plus 2 cubed on top. Now, when we find the derivative, this first derivative, the derivative of 3x minus 1 squared, we use the chain rule, or the general power rule. So we bring the exponent 2 down. We decrease the exponent on the parentheses by 1. Well, when we decrease 2 to 1, that's just, 2 by 1, we just get an exponent of 1, and so I'm not going to write the exponent of 1. But then we also have to remember that we multiply with the derivative of what's inside. And the derivative of 3x minus 1 we recognize is just 3. Now we have the subtraction sign. And behind the subtraction sign we have 3x minus 1 squared. And then we're looking at the next derivative. Well, the next derivative requires the general power rule again, because it's parentheses with a power that we're taking the derivative of. So we bring the exponent down, the 3. We reduce the exponent on the parentheses by 1. So now we have an exponent of 2 on the parentheses. But don't forget, we have to multiply with the derivative of what's inside. And the 5x plus 2 is inside. The derivative of 5x plus 2 is simply 5. Now we turn our attention to the denominator. And notice, of course, when we have something that has an exponent on it to another power, remember we multiply the powers. That is, we have a to the m power raised to the n power. Then what we do is we multiply the two powers together. So in this case, the two powers are 3 and 2. We multiply those and we get a 6. And so the exponent we have is 5x plus 2. The exponent is a 6 in the denominator. Okay, we still have cleaning up to do. Now, a common error at this point is to try to cancel a 5x plus 2 in the numerator and a 5x plus 2 in the denominator, but it's too soon because we can't cancel until we have the numerator factored. And so we're going to go through a process, but before we factor, we need to simplify, kind of like we've done before. So we look up at the numerator, and on the left side of that subtraction sign, we have a 2 and a times 3. So that's a 6. And then we have the 5x plus 2 to the power 3 and a 3x minus 1 up there. And then we have the subtraction sign. And when I look over here, I have a 3 and a 5, and so that multiplies to be 15. And I'd like to write these in the same order, so I'm going to write the 5x plus 2 over here before I write the 3x minus 1. But the 5x plus 2 has an exponent of 2, doesn't it? And then I have the 3x minus 1 that also has an exponent of 2. And down at the bottom, I have a 5x plus 2 to the power 6. Now, I'm concentrating on the numerator because I want to factor that numerator so that maybe I can reduce the fraction. And that looks kind of like what we've been factoring before. So I compare the 6 that I have here and the 15 that I have here and say, do I have a common factor? Of course, 3 goes into both of those. So 3 is a common factor. And then I'm looking at the 5x plus 2 that I have here, and I also have one here. So 5x plus 2 is a common factor. But you factor out the lowest exponent, and the lowest exponent is a 2. And then I see I have a 3x minus 1 here and a 3x minus 1 here. So 3x minus 1 is a common factor. But the lowest exponent here is in the first one because we don't see an exponent, we know it's 1, so the exponent 1 is the lowest exponent. Now all of that was a common factor. So now I think backwards, I think what do I need to multiply by or with to get what I originally had? And so I'm thinking 3 times 2 gives me the 6 at the beginning of this one. That was this 6 right here, isn't it? And I need a 5x plus 2 to the third power. See, I need that right here. And I'm multiplying with a 5x plus 2 to the second power. So I need a 5x plus 2 to the first power in this position. Now I need a 3x minus 1, and I'm multiplying with 3x minus 1, so I don't need an extra 3x minus 1. So now I'm at the subtraction sign. And so I'm asking, 3 times what will give that 15? Well, 3 times 5. And I'm thinking, okay, I need to create a 5x plus 2 to the second power, but I'm multiplying with 5x plus 2 to the second power down below. So I don't need any more 5x plus 2's. But I need to create a 3x minus 1 to the second power, and I'm only multiplying by 3x minus 1 to the first power below, so I need another 3x minus 1 to create this 3x minus 1 to the second power. And I think that completes what I need. And then, of course, I have a 5x plus 2 to the sixth power still below here. Now, we've seen this idea before. Let's go in here. Here's my g prime of x. Okay. And inside those brackets, I can simplify. So I'm just writing out everything before the brackets. Now, inside those brackets, recognize what we're going to have. See, this 2 times 5x plus 2, see, that's going to end up being 10x plus 4, isn't it? Now, in this case, over here, we're actually multiplying with a negative 5. Negative 5 times 3x is a negative 15x. And negative 5 times a negative 1 ends up being a positive 5, doesn't it? So what I'm having in those brackets, if I multiply it out and simplify, I'll have a 10x minus 15x, which is negative 5x. And I'll have a 4 plus a 5, which is a plus 9. So everything in those brackets simplifies to just negative 5x plus 9. And in the denominator, I have a 5x plus 2 to the sixth power. So I have the numerator completely factored and the denominator completely factored. So I look for places that I can cancel. And I'm zeroing in on this idea. On top, I have 5x plus 2 to the second power. And on bottom, I have 5x plus 2 to the sixth power. And so I really have left from this part a 5x plus 2 to the fourth power down below, don't they? The two of the factors on top cancel with two of the factors on bottom, leaving four factors on bottom. So when I rewrite this, on top, all of the 5x plus 2 squared cancels. And so that's gone. I have 3x minus 1 and negative 5x plus 9 left. And on bottom, because of the cancellation of those 5x plus 2's, I just have 5x plus 2 to the fourth power. So that would be the final result of our derivative, which of course was quite extensive. Okay. The last problem that I want to do of these general power rules is more about finding the equation of a tangent line. And we'll do that on the next page. Okay, for our last problem, dealing with the general power rule, a special version of the chain rule, we're asked to find the equation of a tangent line. Find the equation of the tangent line to the graph of y equal x cubed plus 7 to the 2/3 power at x equal 1. Now, we've been through this idea several times. Let's remember the components that are necessary. We're going to use y minus y sub 1 equal m times x minus x sub 1 to come up with the equation that we're looking for. But to use this point-slope form requires knowing a point. So it requires a point. And that's the x sub 1, y sub 1. And it also requires the slope. Okay? Now, we've had this discussion before. We're talking about the equation of a tangent line. But that tangent line shares a point with the graph. And the point it shares is when x is equal to 1. So what we have to end up doing is finding the y value of the point. We know x is 1. And the y value of the point, of course, we put a 1 in for x. So y will be equal to, instead of x cubed, 1 cubed plus 7. And that's to the power 2/3. Now, Of course, we know 1 cubed is 1, and so we really have y is equal to, so it's getting a little crowded there, 8 to the power 2/3. Now, I suppose we could pull our calculator out real quickly, but I'd rather you understand the algebra behind these things. That will help us in the long run do more complicated problems. Remember, a exponent of 2/3, the denominator of the exponent is the index of a radical. And so that means that 2/3 means we actually have a cube root, doesn't it? And it's the cube root of 8 to a power, and the numerator of that exponent is the power that's on 8. Now that's one way to write it. An alternative way to write it is that we have a cube root of 8, and the exponent is on the cube root. Now, this actually is a little better way for us in this problem, because we can calculate that the cube root of 8 is 2. That's this cube root of 8, and we have an exponent of 2 on that, and so our y is actually 4. So the point that we need to use has an x value of 1 and a y value of 4. So we've got this part taken care of, don't we? Now, for the slope, to get the slope, say, to determine the slope requires finding the derivative. It requires finding the derivative of y with respect to x. And if you remember, the reason is that the slope of the tangent line is the derivative evaluated at the x value 1. Remember, the derivative is a slope generator. It tells us how to calculate the slope of a tangent line for a particular value of x. So we've got to find the derivative of y with respect to x, which is the biggest part of this problem. So we begin, in fact, let's go to the next page. Let me pause here, and we'll start this at the next page, and then we'll have enough room to finish it. Okay, let's remember our function, since we've turned pages here. Let's remember our function is y is equal to x cubed plus 7 to the power 2/3. And what we need to do to find the slope is calculate the derivative of y with respect to x. So we needed the derivative. Now, this requires the general power rule. We have parentheses to a power. And so the general power rule requires that we put the exponent in front, so that's 2/3 of the parentheses. And then we calculate the new exponent by taking the old exponent and subtracting 1. And then we have to remember that we also have to multiply with the derivative of what's inside the parentheses. And so we've got to calculate the derivative of x cubed plus 7. Okay, well, let's continue. The derivative of y with respect to x, then, is 2/3 times x cubed plus 7. And, of course, 2/3 minus 1 is the same as 2/3 minus 3/3. 1 is 3/3. And so you see that's a negative 1/3. Okay? So our exponent is negative 1/3. And then we look over here at the derivative of x cubed plus 7, and we can determine real quickly that that's 3x squared. Now, normally, and let me point this out. Normally, when we're looking to find a derivative, we want to make it as simple of a situation as we can. That is, we want to write all that out, simplify it, and that's okay. But what we're after here is really a number. We just need to know the slope, and that means we just need to put 1 into the derivative. So we don't have to simplify. Although we could, we don't have to. Okay, so I'm just going to make that suggestion now. To find the slope, we just need to know what the derivative value is when x is equal to 1. That means we would plug a 1 in for each of these x's. Okay, so it would look like this. And of course here we would have 3 times 1 squared here. Well, as we calculate, inside these parentheses, 1 cubed is 1, and 1 plus 7 is 8, so this is 8 with the exponent negative 1/3 on it. And of course out here we have 3 times 1 squared. 1 squared is 1, 3 times 1 is 3, so it would look this way. And now we can notice, of course, that the 2/3 times the 3 is just a 2. So this is 2 times 8 to the negative 1/3 power. Well, now we do have to do a little bit of work. We need to rewrite the 8 to the negative 1/3 as 1 over 8 to the positive 1/3. And then we need to recognize, let's come over here, 8 to the 1/3 means cube root of 8 to the first power. And we recognize the cube root of 8 is 2. So we can replace this. Instead of saying 1 over 8 to the 1/3, that's a 1 over 2, since 8 to the 1/3 is 2. And of course, 2 times 1/2 is 1, isn't it? Okay, now let's kind of summarize where we are. We found out that the point that we're going to use, a moment ago, we found out that the point was what? 1, 4, and now we know that the slope is 1. So when we plug into the y minus y sub 1 is equal to m times x minus x sub 1, our y sub 1 is 4, our slope m is 1, x minus our x sub 1 is 1. Well, that becomes y minus 4, and 1 times x minus 1 is just x minus 1. We'll add 4 to both sides, and that simplifies, you can see, to y is equal to x plus 3. So here's the slope of the tangent line at x equal 1. Well, this concludes what I'm going to do with the chain rule, or for now, that is the general power rule. We'll have to come back to the chain rule when we have different kinds of problems. But that's all for now. Good luck on your homework.